Hi, welcome back to Wings lecture. I'm Vetri. In this video, we are going to see about Tower of Hanoi. So, what is the problem is about? A Tower of Hanoi is a mathematical puzzle problem. So, the task is we are going to move n disk from peg A to peg C. Here, peg, which is nothing but the towers we are having A, B, C. So, these are the three rods or three pegs. Okay, the task is we have to move all these n disk from A to C. So that is going to be the task, and for completing this task we have to follow some certain rules. The first rule is you can take only one disk for one move, one disk for one move. And second one, so you have to take you can take only the upper disk from the peg. So you cannot take the middle one or the last one. Okay, so you have to always take the upper one for moving. Okay, and the third one is going to be, so you cannot keep a big disk on top of the small one. So you cannot keep like this. Okay, always you have to keep a small disk on top of the bigger one. So this is the right format. Okay, so that's all about the problem and the condition. So let me teach you how to solve this problem and how to write recurrence relation for this, and how to find out the time complexity for completing this algorithm. First, let me write the algorithm. So here I am going to take the function void Hanoi. So here I am going to pass the variable integer n, which is nothing but number of disk, and string A, string B, and string C. So in this case I am going to, so here let me explain the parameters. Here n, which is nothing but number of disk, and A, which is nothing but the starting rod, which is the disk is present in this rod, and B, we are going to move all the disk to the destination. This is going to be the destination rod, and final one, string C, I am going to use this one as auxiliary rod. Okay, so let me write the function. First I have to check the condition whether if the number of disk is equal to 1. So if there is only one disk, means so there is no swapping is need to be done, which means no there is much process. Simply you can move from A to B, right? So the function called move A comma B. Okay, so else if there is more than n disk, what you have to do is we are going to introduce the function. We are going to call the function again recursively by, for n minus 1 disk, the input is going to be n minus 1 from A to B using C. Okay, so then after that you have to go for move from A to C, and again we are going to call the function recursively, the function which is nothing but Tower of Hanoi. So n minus 1 disk from B to C by using A. So while seeing the example, you will know how it is going to get worked. Okay, so let's start with the example. Okay, see, I'm keeping over here so we will get enough space. So let's see, here we have the disk 1, 2, 3. So first step, so this is the initial condition. On first step, what I am going to do is, first I am going to move So as per the rule, we can take only the upper one. So first I am going to keep the first disk to C, okay, and then second I am going to take the second disk, small one, the second disk to B, and third disk will be here, okay, in the second step. On third step, so I am going to bring this small disk to B, okay, so and that's how now C will becomes free. So A, B, C. The next step, step 4, A, B, C, and step 4 I am going to move this big disk to C, okay. Now A is empty. On fifth step I am going to move this smaller one to A as per the algorithm. So I am going to move the smaller one to here, and the second biggest and the biggest one. It will be look like this on fifth step. On sixth step, I am going to keep the second biggest one on top of the biggest one, okay. Now A, B, C. Let's take now on seventh step. So here is the condition, as here is the case that we have only one disk. Simply you can go for the last move like this, right? So now we have placed, we have moved all the disk from A to C, right? By following all the condition, right? Now let's compute that total number of moves we have consumed, took. So totally 7 moves we have took, right? From the initial condition. Now total number of input. So n, what is the value of n? Here I have took 3 disk, right? N is equal to 3. Okay. So let me compute the time complexity C. Now for completing from this position, which means let's go to the algorithm again. For completing this process, I am going to take the whole function. For computing tower of Hanoi, I am going to take T of n, okay. And for computing n minus 1, so then how we can do? For computing n minus 1 times to perform this function. So this is n, and here the input is going to be n minus 1. So as per the mathematical rule, so I am going to consider T of n minus 1 times, and then so here what is it? It's a 1 move, okay. And again for computing n minus 1 step, n minus 1 move, so it will consume n minus 1 time unit. So totally here we have 1. So totally how we can define T of n? See, T of n minus 1 plus 1 plus T of n minus 1. So the total time complexity would be T of 2 T of n minus 1 plus 1. So this is going to be the recurrence relation for tower of Hanoi problem, tower of Hanoi algorithm, okay. So how to solve this tower of Hanoi algorithm by using backward substitution method? So let me solve this. So let's have a look. So what you have to assume is, if T of n is equal to 2 T of n minus 1 plus 1 for if the input is more than 1. Okay, so or else if the input is 1 means we'll get the time complexity as 1, because for moving 1 A to B means there is nothing on it, right? Directly we can move the disk. So from these two, no need to use the C, or if we are about to move A to C means no need to use C, directly you can move over here, right? Now I'm going to take the relation for this case. If n is equal to greater than 1, 2 t n minus 1 plus 1. Now let us consider. So I need the value. Now I am going to compute this by applying backward substitution method. So I need the value which is t of n minus 1, otherwise I cannot solve the problem, right? So first let's compute a t of n minus 1, which is, so you have to apply the value, you just replace n with n minus 1, that's it. So here we have the t of n value. So t of n is equal to 2t of n minus 1 plus 1, right? So t of n, it is going to be 2 into t of n minus 1, already there is 1 minus 1 plus 1, right? So it is going to be 2 into n minus 2 plus 1. The t of n minus 1 value is going to be this. So I am going to apply this value in this place. So what would be the value? Already we have 2, I'll change the color for better understanding. Already we have 2 and plus 1, right? So instead of this part t of n minus 1, I'm going to apply this value. Okay, so what is the value? Wait, let me write in red color, then you will get a clear idea. So 2 t of n minus 2 plus 1, right? So that is going to be the substitution. So after that, let's see, I am going to take this one as 2 into 2, I am going to take 2 power 2 t of n minus 2 plus, so after multiplying with this, what will be the value? 2 plus 1, finally 2 power 2 into n minus 2 plus, totally I can call this one as 3, right? So this is how we are going to substitute the values. Okay, so instead of this, what I am going to do is I am going to keep like 2 over here plus 1. So I am not going to change this for creating the relation, otherwise it will be a bit difficult for us to compute the algorithm what we are expecting. Okay, so let's see. Next I am going to apply, I am going to find out for computing the same, I am going to find out t of n minus 2. So t of n minus 2, already we know the value t of n minus 1, right? So t of n minus 2, which is nothing but it is going to be 2 t of n minus 3 plus 1. So by applying this value, so what would be the result? Let's take, so already we have 2 power 3 and so instead of 2 power 2 you can keep 4 also. Okay, so that's not an issue. So why I am using 2 power 3 means to relate with the relation. Okay, finally you will know how we are going to apply the constant values. Okay, now by applying this 2 power 2 and 2 into t of n minus 3 plus 1, already we have plus 2 plus 1, right? So what is it? So here I am going to take this 2 over here, 2 power, because obviously it is going to be 8, so I am keeping 2 power 3 into t of n minus 3 plus, after multiplication it would be, so what will be the value? It is going to be, yes, 4 and 2 plus 1. So finally what would be the result? Yeah, so 2 power 3 t of n minus 3 plus 4 plus 2 plus 1. So I hope I have clear up to this step. Okay, sorry, let me move the screen. So here we have got the final solve, and it's not going to be final, but just consider this is going to be the final recursive relation. So if you are about to increment this, so it will go like 2 power 4 t of n minus 4 plus, so it will start incrementing on it. Okay, so there it will be 8 plus 4 plus 2 plus 1. So it will go like this, right? So how we can by applying some constant values, it will meet the solution for solving the recurrence relation. So what I am going to do is, I am going to take, so here I am going to take the constant value, which is the first one, it is going to be 2 power, let me strike out this, otherwise it will seem slightly bigger than the expected one. Okay, now I am going to consider 3 as k is equal to 3. Okay, so 2 power k t of n minus k plus, how can I write this? Before that, how can I write this equation? 2 power 3 t of n minus 3 plus 2 power 2 plus 2 power 1 plus 1, right? This is how we can write, right? Obviously it is going to be 8 t n minus 3 and plus 4 2 plus 1, right? And that's it. Now I'm going to consider 2 power 2 here we have it, right? So how can we write? K value is 3, so I'm going to write k minus 1 plus 2 power k minus 2 plus 2 power 1. Okay, and so now we have got the solution, which is I have applied the constant value, right? Already we know that what is the value of, initially we have assigned that t of n is equal to 1 means we know the value which is 1. Okay, so what we supposed to do is, first we have to assign that, see, we know the value t of 1 is going to be, as we know the value of t of 1 is going to be 1. So here I am going to assume the values. So for that, for achieving this, I have to make n minus k as 1, and then I am going to take k value as n minus 1. Okay, so let's see, n minus k, so assume n minus k is going to be 1, I am assuming that, and k, so what will be the value of k? N minus k is equal to 1 means k is equal to 1 minus k is equal to 1 minus n. So if you multiply it with minus again, what will be the result? N minus 1. So this is going to be the k value, and I am going to take n minus k is going to be 1. So by applying this, what would be the result? 2 power, so instead of k we have to use 2 power n minus 1 t of 1, which means we have assigned n minus k is equal to 1 plus 2 power k, for k we have to use n minus 1, then what would be k n minus 2 plus 2 power n minus 3, it will go on plus 1. Okay, so let us consider this equation as x. Okay, so if you simplified it, what would be the result? 2 power n minus 1 plus 2 power n minus 2 plus 2 power n minus 3, it will go on like this. Okay, so now what I am going to do is, for solving this problem, I am going to multiply, because I have to find out the simplified equation, right? So I am going to multiply this equation, so take this one as equation 1 and do it by multiplying 2 with this. So I am going to multiply equation 1 by 2. So what will be the result? Left hand side would be 2x, and here how it will become? 2 power n plus 2 power n minus 1 plus 2 power n minus 2 and so on. This constant 1 will become 2. So let us consider this equation as 2. Okay, so now what we have to do is we have to subtract these two equations for obtaining the final solution. So subtract 1 from 2. Okay, so now by subtracting this, what would be the result? Obviously 2 power, so here it is going to be equation 1 is 2 power n minus 1 plus 2 power n minus 2 plus 2 power n minus 3. It will go on like this, and equation 2 is, this is equation 1, and equation 2 what we have obtained, 2 power n plus 2 power n minus 1 plus 2 power n minus 3, sorry, n minus 2 plus 2 power n minus 3. It will go on up to 2, right? Now, so if I am start removing the common terms, n minus 1, n minus 2 and n minus 3, so it will, we will remove all the relations like 2 power n minus 1 on, right? So if you deduct with this constant value, here we have 1 and 2, so obviously it is going to be minus 1. So what would be the result? The balanced terms are 2 power n minus 1. So this is going to be the time complexity of this algorithm. So how we are going to summarize this? See, T of n is going to be 2 power n minus 1, right? So the next thing is, you can take sir, if n is equal to 3, that was the example which you have seen, right? If n is equal to 3 means the total moves would be 7, right? So let's check with this n value. If T of 3 is equal to 2 power 3 minus 1, so what would be the answer? 8 minus 1, it is going to be 7. So time complexity of 3 input is going to be 7, right? So hence we have proved it. Then what would be the time complexity of this algorithm? So already we have found the time complexity, which is T of n is going to be 2 power n minus 1. It is going to be the exponential one. And as we know that, so if it is 2 power n means what would be the time complexity? So from the order of growth, we know the growth, so that is a linear, quadratic, cubic and exponential, right? So exponential, these three categories are comes under worst case, which is big O, and here it is nothing but the time complexity is going to be big O of 2 power n, that is going to be exponential. Okay, so I hope I have got a clear idea about how to solve the Tower of Hanoi problem and how to compute the time complexity by using mathematical substitution method. Okay, sorry, backward substitution method. And if you have any doubts, you can comment in comment section, and thanks for watching.